demonstrating here is this is a Lamont turbidity meter, and what it does is it uses light, and the light shines through the water sample and measures how well the light could go through the water. That measures turbidity. So turbidity is what is suspended or mixed in the water. So here's our river water, and you can see, we could say it's obviously not clear, but this is going to measure it with a number. This is distilled water that we'll use as a reference. So this is kind of like our tap water, and this is our test water, our sample water. So basically what we do is we fill up one of these vials, we put it into the machine, push a button, and it then gives us a number that we'll record, and we will compare our distilled water to our sample water. Okay. So what we'll do first, and Michaela, can you pour some of that DO water in here? We're going to transfer the water into that beaker first, and then we'll pour it into the vial and put it into the meter. Okay, that's plenty. So what we're going to do is we're going to take a little bit of this water sample, and you guys can go ahead and pour it in up to that white line, and if you spill some on the table, that's okay. Okay, that's good. And then we put the cap on, and then we simply just put that into the meter. We align the reference line with the arrow, put it in there, turn it on, and I calibrated this weekend. Again, like all these things, you have to calibrate, and now we're ready to measure. So push enter. Go ahead, push that enter button, one of you guys. And we're not using a blank. I already calibrated with a blank, so go ahead and push enter again. And now scan sample. One more time. And then it's going to give us a number. Go ahead and read that number out loud and then write it on your paper.
0.18.
And what does it say though?
MTU.
NTU. That is a type of measurement for turbidity. So that is our control, which is our distilled water. What this is showing us is this has things in it, but a very, very small amount. So that's really what matters for right now. Okay, so that's that sample. So what we're now going to do is we're going to do the same thing now, and we're going to compare that to our river sample. Okay, so now we're going to fill up a second vial with our sample water, and we're going to repeat the test. And that'll work, that's fine. So we're going to put the tap on, or the tap on. It's a tap instead of a cap. And so I'll let you do it this time. You see that line is going up and down, that's the reference mark, and see the arrow. Just align them up, push it all the way down until it clicks. Now shut the lid. There you go. And now go ahead and power it up again. Here we go. It's being stubborn. And so now we click measure. Go ahead and scan sample. And there we go. Okay, so now what does that number say?
39.6 NTU.
So this is 39.6 NTUs. What we want you to see here is a very significant quantitative difference. Okay, so we're now going to put that data up on the board, and we will continue our comparison between tap and distilled water versus our river sample. So welcome back. The next part of our process is we're going to take our measurements, our data, and we're going to compare and interpret them. So when we have data like this in science, we call it a quantitative measurement. It is a relatively accurate, precise data value. We measured the values using our YSI probes that we took to the river, and as you can see, we also did a set of measurements for the tap water. The tap water is acting as our control. And it's important we understand why we have a control and why we have test samples. These are our variables over here. So the first question I'd like to ask you folks is, why do we have the tap water? Why do we have a control? Raquel.
Well, we use the tap water as a control because we know the qualities of tap water, and because we know those qualities, we can measure them against whatever we take from the samples so that we have kind of a general knowledge basis of what to expect, or what we want to expect for the river.
Great, thank you. Another thing I would like you to see is if you look at the data, you'll notice for the river samples, we did it 3 times. We call this multiple measures. This is very, very important in science. You understand this. If you've taken a stats class, you've talked about this, the number of samples you have. So we took 3 water samples. Can someone tell us why would we do that in science? Any ideas out there? What do you think? Shiloh, what do you think?
So we get the same results each time we measure.
Exactly. Continuing now, we're going to specifically look at some of the data values. So we've measured dissolved oxygen, and as you can see from the table, we measured it 2 ways. In this first measurement type, milligrams per liter, that's how much is in the water. The second way we measure oxygen with our meter is by percent saturation. And what that's measuring is how much of the oxygen that the water can hold is in the water. So what I'd like you to do is compare this pattern within the river sample to this pattern within the tap water and see if you can explain to us the relationship between those 2 types of measurements. So who'd like to try and do that? Casey.
There's more oxygen in the sample since the water is more saturated, as seen in the data.
Great, thank you very much. The next parameter, which is always used in any type of water quality analysis or any basic chemistry class, is the concept of pH. So we're going to talk about what is pH, what makes it acidic or basic, and then if we look at our data, we're going to compare the difference between the river water and the tap water. So in going over those ideas of what is pH, what makes it acidic or basic, who'd like to answer that question? Nick.
pH is a number scale used to determine if a liquid is acidic or basic, and liquids that have a pH higher than 7 are basic. The tap water is more basic than the river water because it has a pH of 8.
Great, thank you, Nick. The next parameter that we measured, and we actually measured this with our colorimeter. It was a different piece of equipment, and you can see the colorimeter that we used at the back of class later if you'd like. But the colorimeter for this parameter measured a thing called turbidity. Turbidity measures how much stuff is suspended or mixed in the water. So if we look at the turbidity of the river sample to the tap water, again we see a significant difference. Who would like to explain to us why you think the turbidity is so different?
River water has more turbidity.
That's right. So our last parameter we want to compare today is looking at nitrate. If you look at the nitrate, again we can see a significant difference between the control or tap water and our sample or river water. So the next question of course is, why does this happen? And then finally, so what? Which we're going to talk about a little bit more next time. So if we look at the data, does someone have an idea where could the nitrate come from? If we look at the river, it has way more nitrate in it. So what's a couple of ways nitrate could get in the water? Any ideas out there? Any ideas? Okay, Christina, how do we get nitrate in the water?
Nitrates can come from fertilizer or from animal waste.
Great, thank you very much. And then finally, so what?
Well, you should care because it's home to animals and we need to drink the water, so it's pretty much necessary for everyone and everything.
Great. Okay. We need to worry about down the road, not just next year, but 40 years from now. Great. Okay, well, I want to thank you for being here tonight, and we will continue next week, and I'll see you next time. Thank you very much.